Okay, today we are doing multiplication properties of exponents. So I can multiply by powers and work with scientific notation. That's what we want to do. And at the end, you can say, I can multiply powers with the same base. Okay, so key concepts are multiplying powers with the same base for every non-zero number. Okay, so we'll just jump to this example. So to multiply exponents that have the same base, so the base right here is 3, 3, 3, 3. So if they have the same base, you just add the exponents. So 3 to the 5th times 3 to the 4th equals 3 to the 5 plus 4. 5 plus 4, and that equals 3 to the 9th. 5 plus 4 equals 9. Okay, so multiplying powers. Rewrite each expression using each base only once. So 7 to the 3rd times 7 squared. Same base, 7. So we put 7. And then exponents, we add. So 3 plus 2, 3 plus 2. Okay, and let's see, I'm going to write 3 plus 2, so 7. 3 plus 2, 5. So it's 7 to the 5th. Okay, so all the same base of 4. So we add the exponents. 4 plus 1 minus 2. 4 plus 1 minus 2. 4 plus 1, 5. 5 minus 2, 3. Okay. Same base of 6. So add the exponents. So 8 plus negative 8. Negative 8. So that's 8 minus 8. So we have a base of 6. Then 8 minus 8 equals 0. And an exponent, that is 0, that equals 1. Okay. So rewrite each expression using each base only once. So same base of 5, so we add the exponents. 3 plus 6 equals 5, same base. 3 plus 6, 9. All right. Same base of 2. Add the exponents. 4 minus 3, 1. So 2. Okay. Same base of 7. So exponent, add the exponents. So we have negative 3 plus 2 plus 6. So that's negative 3 plus 2 plus 6. Okay, so that equals negative 3 plus 2, that's negative 1. And then negative 1 plus 6, 5. it's 7 to the 5th. Okay, so did that page. Multiplying powers in an algebraic expression. So p squared times p to the 5th. All a base of p, so we write p. And this, if it's just this number, then we know it's implied that the exponent is 1. P to the 1. And that's why we have 1 here. It's squared, so p squared, p to the 1, so 1, p to the 5th. So it's all p, base of p. So add exponents. 2 plus 1 plus 5. 2 plus 1, 3 plus 5, 8. Okay. So this is 4x to the 6th times 5x to the negative 4th. So we have the same base right here, x. And so we'll group these numbers beside the x's together, and then the x to the 6th, x to the negative 4th, put them together. So 4 times 5 equals 20. And then we add our exponents. So 6 minus 4, and so that's why they have x6 plus negative 4. So we'll write in 20, that's the 20, times x, same base. 6 minus 4, that's 2, so x squared. Okay. Next, 5x times 2y to the 4th times 3x to the 8th. Okay, so we will group the bases that are the same. So these are all numbers, 5, 2, and 3. So they will all go together. Okay, and then we have the x's right here. So we put the x's together. X to the 8th times x to the 8th. And then we put the y, because it's its own thing. So we put the y over here, y to the 4th. And then we multiply the groups. What's inside each group? We multiply that. So 5 times 10 times 3. So that is 5 times 2. That's 10 times 3, 30. Okay. Then same base, so we add the exponents. And if it's just this, we know that it's implied, it's x to the 1. That's why they have x to the 1 here. So x, 1 plus 8, that is 9. So we'll keep going with this. So 30, 1 plus 8, x to the 9th. Okay, and y to the 4th, y to the 4th, y to the 4th. Okay. So, yep, that's your answer. Simplify each expression. Oh, these have the same base right here, n. So we put them, and actually have an n right here too. So we're just going to say 7 n this is 1. So 1 plus 3, that's 4, plus 2, 6. So, or you could say 2 plus 3, 5, plus 1, 6. We'll do this one. So we'll group the same bases together. So we have 2, this is a number, this is a number, 7, and this number, 2. Okay. And then we have y's. So we have y to the third, and we have y to the fourth. Okay. And then we have x squared. X squared. Okay. So 2 times 7 is 14. All right. And then times 2 is, let's see, 14 times 2. I'm pretty sure, but let's see. Yep, 28. Okay. So 28. And then 3, same base. So we add 3 plus 4. That's 7. Y to the 7. And x squared. Okay. So we got it. Okay, so this is, we have different bases, so we will group our bases. So a squared, that's 1, and a, this is the other a, so 5. So 2 plus 5 times, and we have our other base, b, so b to the negative fourth, b to the negative fourth, equals, now this is a 2 plus 5 equals 7, and this is positive, so we put it in the numerator. And this is a negative exponent, and we put the negative exponent in the denominator, and we change the sign from negative to positive. All right, so then it becomes this right here. All right. Similar problem. So we have different bases, Q and P and Q. So we put the Q's together and we put the numbers together. So 2 times 3 times 4. Okay. And then we have the base right here of P3, P to the 3. And then we put our Q's together. So Q times Q to the 4th, Q to the 4th. And 2 times 3 is 6. 6 times 4 is 24. And then P to the 3rd. And then Q times Q to the 4th. So we add, this is Q, that's like Q to the 1. And you see Q to the 1 right here. So 1 plus 4 equals 5. So we'll just write that out. 24 P to the 3rd times Q to the 5. 1 plus 4 equals 5. Okay. Simplify each expression. So we have A, we have A. These are two bases, A and A. This is like A to the 1. So 1 plus 5 is 6. And then we have our B right here. It's a different base, so we don't put it with the A. Okay. 6y squared times 3y to the third times 2y to the negative fourth. So we'll put our numbers together. So 6 times 3 times 2. Okay. And then we'll put our y's together. Y squared times y to the third times y to the negative fourth. All right. 6 times 3, that's 18. And then 18 times 2 is 36. And then we have base of y, so we can add these exponents. So 2 plus 3 is 5. 5 minus 4 is 1. So that's y to the 1, or just y. Okay, and that's it for that. So, move to the last page, just these two problems. So this is 3 times 10 to the negative third times 7 times 10 to the negative fifth. So again, we put our numbers together. 3 times 7 right here. And then, I'll just put a little right there. And then 10 times, we put these together. So 10 to the negative third times 10 to the negative fifth. 3 times 7 equals 21. And then same base, so we add them together. So negative 3 plus negative 5. So negative 3 plus negative 5 equals negative 8. So now it's 21 times 10 to the negative 8. But we want this 21 times 10 to the negative 8 to be in scientific notation. So let's see if I can write scientific. Scientific notation. Yes. This right here, that's scientific notation because you see it needs to be between 1 and 10. 21, it's way over here. 2.1, yes. 2.1 is in between 1 and 10. So that's why we put it as 2.1 times 10 to the negative 7. So, and we can explore it a bit further. So we have 21 times 10 to the negative 8. What that is we have, if we want to write that out, that's 1, 2, and then 6 zeros. So 1, 2, 3, 6. And then we have 2, 1. So then we can check. So 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's what it was. But now we want the answer. We want this 2.1 right here. So to get to 2.1, it's 1, 2, 3, 4, 5, 6, 7 right here. And that's why it's 10 to the negative 7. Okay. So I'll just write, yeah, I think that's fine right there. Yeah, so that's why we have, that's good. So, simplify each expression, write each answer in scientific notation. Okay, so what we need to do is we need to put the numbers together. So 2.5 times 6. 2.5 times 6. Good. And then we put the same base and exponent together. So it would be 10 to the 8th and times 10 to the 3rd. There we go. And then 2.5 times 6 equals 15. And then 8 plus 3. So we have the same base. So we keep the same base. Then 8 plus 3 equals 11. Okay. But now we want the answer to be in scientific notation. So this is not between 1 and 10. It needs to be between 1 and 10. So we want it to be right here, 1.5. We want 1.5 times 10 to the something, because 1.5 is between 1 and 10. So let's see. We'll put this in scientific notation, or we'll write this out. So this is 15 times 10 to the 11th. So it's 15, and then 11, so we have 11 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, a lot of zeros. Okay. Now, what we want the decimal to be right here. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So that's why the answer is 1.5 times 10 to the 12. Okay. I'll put it right in here. 1.5 mark this off. There we go. Okay. B. So for B, again, put the numbers together. So 1.5, and say times 3. And we put numbers with exponents together. So that's 10 to the negative 2, 10 to the negative 2, times 10 to the 4th. All right, so 1.5 times 3, that equals 4.5. And then 10 to the negative 2 times 10 to the 4th, same base. So it's negative 2 plus 4. That is 10 squared, right? Or you could say 4 minus 2, 2. Okay. And so this is already in scientific notation. It's 4.5 times 10 squared. So we'll put it up here. 4.5 times 10 squared. See, 4.5 is between 1 and 10. Okay, and the last one. So these are, we'll put the numbers together, so 9 and 7. So 9 times 7. And then we'll put the numbers with exponents together. So 10 to the negative 6 times 10 to the negative 9. Okay, so 9 times 7, 63. All right. And then same base, so we add. So we could say negative 6 plus negative 9. So that equals, it's the same as saying 6 plus 9, and it's negative. So it's same base, 10. So 6 plus 9, that's 15. And it's negative, negative, so negative. So negative 6 plus negative 9 equals negative 15. Okay. Now, let's say what this equals if we write it out. This is a very long one. So we first have 1, 2, and then 13 zeros. So we have 13 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 6, 3. Okay, right? Because you do 1, 2. So we took 2 off 15. So that's 13. So now 13 zeros. Okay. Now, we want it to be at 6.3 right here. So let's count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 14, negative 14, not negative 15. So it's 6.3 times 10 to the negative 14. Okay, so I'll write it up here. This is the answer. 6.3 times 10 to the negative 14. Okay, and that is it. So that is it for the multiplication properties of exponents. Have a good day.